Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. 2019 question 4, coordinate geometry. The circle question on the Leaving Cert ordinary level was: the circle C is enclosed by the square PQRS and touches all four sides as shown in the diagram below. The coordinates of three of the vertices, which is just corners, is 2, 3, 4, 17 and s to the minus 4, 11. Find the coordinates of Q, which is over here. Okay. Well, a circle is symmetrical, a square is symmetrical. So you can use translations to find out the point Q. So in other words, have a look at how far or is from S, and then Q will be the same distance from P. Okay, so let's try that. So we have minus 411 to 417. So that's a change of minus 4 to 4 is a change of x, of 8 in my x direction, and in my y direction 11 to 17 is a change of 6. Okay, so therefore then you take your point P, which is 2, 3, you apply the same change. In other words, you add on 8 to your x and you add on 6 to your y, and you see where you end up. So your x is 2 and 8, which is 10, and your y is 6 and 3, which is 9. So he is the point 10, 9. Okay, find the coordinates of the center of C. So to get the center of C, it is going to be halfway through any of the diagonals. So I could get halfway between 4 and 17 and 2, 3, or I could get halfway between S and Q. Okay, I'm going to choose P and R. Okay, just in case I make a mistake in the piece I work out, it is always good practice to use the points in the question to protect yourself in case you made a mistake. So the coordinates of the center C is the midpoint. So back you go to the coordinate geometry, the line, so you can get the midpoint formula, because the center is always the midpoint of either a diameter or a square, whatever. And you'll see that the formula reads as x1 plus x2 over 2. Just write that a bit better. x1 plus x2 over 2, comma, y1 plus y2 over 2. A comma between them because it's the midpoint, so it's a point. So a comma between the x and the y coordinate and brackets around it. Okay, so we are going between R and P. So R is 417, P is 2, 3. So let's label them x1, y1, x2, y2. So it's equal to x1 plus x2 over 2, y1 plus y2 over 2. Now I'm getting 4 and 2 is 6 over 2 is 3, 17 and 3 is 20 over 2, which is 10. Okay, so that's the midpoint. I then have, just for my own sanity to check my answer, I'm having a look at what would be halfway between these 2 points. So I'm going from minus 4 to 10. So that's a difference of 7, minus 4 to 10, that's a difference of 14. So halfway of that would be a difference of 7. So minus 7 from the 10, and you would end up with 3. Okay, so that makes sense. I then compare my y values and I see I go 9 and 11. Well, halfway between 9 and 11 would be 10. And my midpoint is coming out at 10. So I'm fairly confident in the 310 and this 10, 9 because it all stacks. Okay, so the length of the radius then, so we've worked out that the center here is 310. Our radius then is from the center out to one of the corners, okay? So the most natural place to draw it is like that. But of course, the radius of a circle can be anywhere, okay? So I think if you draw it from here out to one of the edges, and it doesn't matter which edge, okay? If I get the midpoint between these two, and then just go from the center out to that edge, won't I have the radius? Okay, so just to explain that a bit more. Okay, just take away some of the red so you can see. Okay, well, why do I need to find the midpoint and go all the way out there? Because at the midpoints, when a circle sits inside a square, is the only place where the circle touches the edge. Okay, so that's a good place to measure radius from. If I go from the red line I've drawn in there now, which is the center out to here, it is indeed a radius, but I don't know the coordinates of here, and I have no way of finding if I got the distance from here out to 417, well, how much do I need to subtract off for that little piece there? And that'll be the same no matter where you get the radius, unless you get it at these 4 points here, which is literally the midpoint between these two. Okay, so that's definitely one way we can do this question. So let's get the midpoint of S and R. Okay, so we're going to take S and R. So S is minus 411, R is 417, x1, y1, x2, y2. Okay, so our midpoint then is, we have the formula here, so I'm not going to write it down again, x1 plus x2, it's this point here I'm getting because I took S and R, yeah. So minus 4 plus 4 over 2, comma, y1 plus y2 over 2. Minus 4 plus 4, so I'm getting the point 0. 11 and 17, 17, 27, 28 over 2 is 14. And I'm looking at that, is that halfway between them? Minus 4 to 4, yeah, it would be 0. Between 11 and 17, 11, 12, 13, 14, yeah, 15, 16, 17. So that's the midpoint. So then I need to get the distance. I'll just come up here if that's okay. Distance between center and that edge. Okay, so I'm going between 0, 14 and my center, which was 310. x1, y1, x2, y2, and the distance of a line is this formula here, x2 minus x1. And you sub that in. x2 minus x1 to be squared plus y2 minus y1 to be squared. And it doesn't matter which of the 2 points you write down first. And I got a distance of 5 for my radius. Okay, so you should get the same answer if you had chosen this midpoint or this one or this one or done it any other way. Okay, now one thing I want to point out to you at this stage is, can you see that we've actually done everything on the line up till now? We used translations, which is kind of on the line, or it's in geometry. We've used a midpoint formula twice. We've used the distance of a line formula or the length of a line formula. So it's only this part D where we actually do something different to get the equation of a circle. Okay, so even if the circle isn't one of your favorite chapters, try and remember that most of it is actually the line. So to get the equation of a circle, we use x minus h to be squared plus y minus k to be squared is equal to r squared. And just up here, just before it, it says given circle hk, so that's our center, given center hk. So we label our center as hk and our radius r. So to find the equation of the circle, we need that center hk and we need the radius r. So x minus h to be squared plus y minus k to be squared is equal to r squared is the equation of a circle. So we need our center, which is 310, and that's our hk. That's what we label it at, what it told us here, hk. And we need our radius, which we just worked out to be 5. Okay, so let's sub in. Well, x stays x, minus h to be squared plus y minus k to be squared is equal to the radius squared. It's tradition not to really work out the left-hand side, but always to work out the radius squared. And that is the equation of that circle C, which is this part here.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.